Hello, welcome to today's Lead Code problem solving session. Today's problem is 286, most profit assigning work. You have n jobs and m workers. You're given three arrays. Difficulty, profit, and worker. Difficulty I and profit I are the difficulty and the profit at ith job. And worker I is the ability of jth worker, that is, the jth worker can only complete a job with a difficulty of at most worker I. Okay. Mm-hmm. Uh, so basically, worker zero can complete a work that has max of like 4, 5. This guy can like do 6. So like he can do these three, and he can do. Uh, he can also do these three only. And every worker can be assigned at most one job, but one job can be completed by can be um, completed multiple times. For example, if three workers attempt the same job that pays $1, then the total profit will be $3. Okay, if a worker cannot complete any job, it's zero. So for this example, the output is 100, and since like workers are assigned to jobs of difficulty 4, this guy can do 4. There's no 5 maximum, he can do like 4, 6, yeah, 6 and 6. But the thing is, this is like a straightforward problem, and like even this is like a straightforward, not problem, but like uh, test case. And even this is a straightforward test case. Kind of got the chance to think of this problem already, and based on what I understand, I can basically tell you that since we have like 2 and 10 here, it's not only the difficulty that we need to consider. So basically, amongst the difficulty, we have to be able to like uh, get the maximum profit for a specific worker. So the idea that I have is that first we sort worker. Like the thing is, difficulty and profit are pairs, because Java has a difficulty like here in the example one, job 0 has difficulty 2 and a profit 10. Job 4 has difficulty 4 and like a difficulty of like as a profit of 20. And you have a bunch of workers who can take jobs of certain difficulty, and yeah, and every worker can be assigned at most one job. So basically the idea is uh, we I mean initially it's thinking of heap. Basically yeah, basically we pair difficulty and output and like sort based on that. And then um, let's say if we're looking at the first worker, and we also sort worker independently, and once we are looking at 4, let's say, we kind of look at difficulty and say that okay, 2 is less than or equal to 4, so we add 2 and 10 as a pair, uh, or we just add 10 into the heap, then we add 20 and we take max. Now that I'm saying it loud, I realize we only need the maximum profit that a certain thing can take. So like we actually don't need to uh, look into like more than don't need to like store something which is lower than the maximum. So we don't need to use a heap, so we could just use max profit is equal to 0 and result is equal to 0. And the way I'm gonna do this is that I'm gonna zip difficulty comma profit. Just wanna see if the spelling's right. Yep. and sort this. And yeah, basically I don't need this like again, so I'm just gonna like start here for range. No, so for like difficulty comma profit, and also like I'm gonna sort the workers. Just gonna see if these satisfy conditions. I think these satisfy conditions. These constraints to satisfy are like requirements for the problem. Instant power for intent power for, yeah. So I'm basically like gonna use a pointer, I guess, instead of just doing this. Just gonna call this work for now, and pointer at 0. For we call it capacity, cap in worker. If cap greater than equal to work, so let's do this a while loop, because we gotta like keep adding the maximum ones. So while cap is greater than equal to work pointer, I basically update our max profit. Yeah, just gonna do this this, I guess. Yeah, also we gotta like make sure that PTR is less than so I think that difficulty and worker have certain lengths, sorry, difficulty and like profit have a length of n. So this should be result, I believe. Yep, I think this should work. Yeah, it's like yeah, this is a brain teaser, definitely interesting problem. It's kind of lucky I got it very quickly. I did take a look at the like problem description like a while ago, so it's not like I'm just looking at this for the first time, but I haven't looked at any solutions. So yeah, anyway, let's look at the performance. Interesting. Index out of range already here. Obviously this is like the most lame yeah, it's like the most lame mistake a person can do in tech. But yeah, we still got a pretty good complexity within the first 10 minutes of our session. So does beat 57%, doesn't get better than that. Yeah, this would definitely be interesting to solve in C++, I guess. And yeah, this would be a greedy problem because we're just taking the maximum and we're sorting can be to binary search. Yeah, I guess instead of manually increasing um, this index, like we are doing it here, instead of just manually increasing the index, we can do a binary search to like find like index between our like uh, pointer and let's look at bisect. Sorry. Thought it like automatically get Python code. I think we need like bisect left, or like do we use bisect right instead? I think we need to like use bisect right. Yeah, but really doesn't make sense in terms of complexity or like making our solution because better, because we will still be like going through all the like, even if you find the best, even if you find our like capacity, like the maximum capacity within the sorted difficulty profit array, we're still going to have to like iterate across the array anyway, so it doesn't make sense to like use any binary search. Yeah, but like lead code loves to put binary search into tags, because like I guess if you can solve a problem like that, they would like it. But yeah, I'm not gonna take any more of your time. Thank you for watching. Peace.